Okay. We're doing this again. So we got the code up and running entirely. We're doing SPIRiT, which means we're trying to estimate missing values in k-space by convolving with a known kernel. And we have the code running all the way through. Our checks for the adjoint, check out. Let's make sure that's correct. Check of W passed, check of A adjoint passed. Great. I believe all this runs to completion. Where is it? Okay. But the image that comes out is bad. There's also this warning popping up telling us that the rank is deficient. And I don't think it should be. I think A should be, so this is basically a matrix that's not full rank. This matrix is not invertible. It wouldn't be invertible, of course, because it's not square, but not full rank. And I think A should be. So there are a million different things that could be going wrong. We're going to systematically go through and check them one at a time. And if they all pass, then we've missed something and we got to do it again. So let's start checking some stuff. The first thing I want to check is just to make sure that these zeros are showing up where I think they should be. So remember, I put a 0 in the convolution kernel at the location where we are trying to estimate the value. I want to make sure they're in the right spot. So W is 5 by 5 by 8 by 8. That's because for each of the 8 coils, we've got a 5 by 5 by 8 quote unquote convolution kernel. It's not a real convolution kernel because we're not, I mean, depends on, I guess, what you mean by convolution, but it's not a 3-dimensional convolutional kernel. It's not a 2-dimensional convolution kernel. So we'll put it in quotes. Okay, anyway, so figure, show image cube. I want to see where the absolute value of W is greater than or equal to 0. And we're just going to look at the values for the first coil. Okay. Are they all 0? They're all 0. That seems to be an issue, doesn't it? And just like that, we've found a problem. Because clearly the interpolation coefficients should not be 0. Why are they? Is A all zeros? Oh, is Y all zeros? Y are all zeros. How about A? A is not going to be. But Y are all zeros. Oh, because I didn't, when I changed Y to B, I didn't change the variable name there. Let's see what happens now. We're still rank deficient. Okay, we sort of got rid of this horizontal streak that was here earlier. So that's better. But this is still clearly bad. I mean, we've got significant aliasing over here, right? Just to recall, the size of the auto-calibration region is 17 by 17. I wish I knew how to not do that. Okay, now let's go through and check the zeros are. So there are way too many zeros in W. So this is the first slice convolution kernel, this is the second slice, this is the third, and this is clearly wrong. When things are clearly wrong, that's good. It means that it's a good clue that something's gone wrong that we should be able to figure out. Now, all of these should be non-zero except for this value here. Everything else should be non-zero. So why are they? Is 225 by 199. There are 30 locations with a min value of 0 right now in A/Y. This is before we added in the 0. Oh. What are the values of sub ACR? So its min magnitude is not 0. There's nowhere in the auto-calibration region with a value of 0. How about Y? There are 56 locations in Y that have a value of 0. Well, that can't be because Y is made up only of values inside the... Oh. I was looking at sub ACR. I need... Here looked at sub ACR. What about ACR? Okay. Inside the auto-calibration region, the entire auto-calibration region, there's no value that has exactly 0. Since Y is made up only of places inside sub ACR, and sub ACR is of course just a portion of ACR, there shouldn't be any values of Y that are totally 0. And yet, if I look at the stats of Y, there are 56 locations that are 0. Okay, and it looks like all indices at 170 and beyond are 0. So we seem to have made y way too big. Now how about a? What if I plot the sum of the magnitudes of the rows of a? Same thing. So the rows of a beyond a certain index are all 0. That explains why a is not full rank. Or maybe that's at least part of the reason. So it looks like I made a and y too big. I don't think I should have multiplied these in half. So there's a cheating way to do this, actually. I'll tell you what that is in a minute. So now y has no values that are 0, and neither does a. The sum of the magnitudes of rows of a all have non-zeros in them. So what's the cheating way? The cheating way is to just let a and y be one value, and then let MATLAB grow the arrays. So let's see what happens if we do that. This is cheating because it's memory inefficient and you can't do it in C. But we can do it in MATLAB, so let's use the tools that we have. So here A is 169 by 199. Who's Y? Y is 1 by 169. $169. So if we just let MATLAB grow the arrays, then A turns out to be 169, have 169 rows. And that's the number we've calculated it out, so that looks like that's right. Okay. See what happens now? Doesn't look any better, does it? And LSQR is completing, so that's not the issue. How many iterations does LSQR run for? The default is 20. What if I set that to 100? Let's just make sure it's not something simple like that. I'm going to get rid of these checks on the adjoint just so that we don't keep having to wait for it. It's taking a lot longer. And now there's a flag. That's interesting. So it looks like LSQR is not completing. Oh, I want to see the flag now. What does a flag of 1 mean? Failure. LSQR reached max iterations but did not converge. So at 20, it thought it converged, but at 100, it doesn't. Okay, that's interesting. And then I think we can also output error, relative residual. What is iter? You can see the final iteration, how many iterations it took. Okay, so LSQR relative residual and LSQR iter. What if we ran it for 1,000? Does it just need a whole bunch? Now, LSQR is very related to conjugate gradient method. Conjugate gradient method shouldn't take 1,000 iterations to converge on a problem like this. Notice we're not getting the issue now that A is ranked deficient, so that's good. We still have terrible aliasing. Okay. Let's take a look at K-space. I'm going to look at it. I'm going to change the intensities to decibels. I'm going to look at the magnitude of the intensities. Okay. So it looks like the interpolation is going poorly. There's clear stripes here. Okay. Let's take a look again at where the zeros are in the interpolation kernel. Let's make sure that's right. Still wrong. Again, all of these should be white except for this one here. That's the only one that should be black. We changed a lot of code to get basically the same result. Just to make sure, figure, plot nice. I'm going to look at the absolute values of y. It doesn't look like any of those values are actually 0. They never seem to get down to 0. If you look at the statistics of y, sure enough, nothing gets down to 0. The lowest magnitude is 0.010, blah, blah, blah. How about the rows of A? Well, now let's look at W coil. It's 199 by 1. There are 30 locations with zeros in W coil, exactly 0. And that just can't be. We should always get at least numerical precision out. So what's the first location? There are 30 locations with this value. Oh, I see, but I didn't actually write. So I created this function stats. And I don't write which locations have the minimum value if there are more than one location, apparently. Open stats. Let's change stats. Let's add some usage in as long as we're here. I like to clean up as I go along. So now if I just do stats, it tells me the usage, great. So a minor code cleanup. What is this pretext? Where does pretext come from? I'm not sure, but I think I set this up. This looks like recursion, right? Oh, no, 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 I see. I just set it up to pass in different types of data. And none of these use a pretext, right? Array stats. Oh, the pretext is just spaces to indent a little bit. So that's this indent here is what that's doing. Fine, okay. Now that wants me to put any there instead of max. Okay. Seems to make MATLAB happy, and that's what I'm here for, to make MATLAB happy. So now I want I want to see them in the locations. So if A equals 1, 2, 3, 4. Okay. I'm just string of A gives me what I want. A equals 1, 2, 3, 4. And I'm just string of A. I don't think this will. Yeah, this gives me what? A 4x1 character array. That's a 4x2 character array. That's interesting. Okay. That is not what I want. So what do I want? Do I already have it here? What is subs? There are 30 locations with this data. So what are subs? Oh, this is me telling you the multidimensional index of the smallest value in a multidimensional array. But now I just want it for I really wish I could figure out this font thing. It's so tough to click find and have it go way over there. So this subs here is me figuring out what the index is, the multidimensional index is into the multidimensional array. And I was only doing that when oh, I see. And I had subs out here because it gets used both for the min and the max. Okay, but like I said, I was only doing that when there was only one location that reached the minimum or maximum value. Now, at least I just want to see the indices. I want at least the 1D locations. So here I'm going to put numDoString in locs. That's going to give me the string that I wanted. Let's see if that works. There they are, the 1D locations. So it's not locs, but it's actually 1D indices. Okay. Let's do it for max as well. There are 3 locations of this value, 1D indices, 4, 5, and 6. There are 4 locations of this value, 1, 2, 3, 4. There are 3 locations of this value. The min is 1. There are 4 locations of this value. 1D indices are 1, 2, 3, 4. The max is 4. There are 3 locations with this value. The 1D indices are 7, 8, 9. I like that. Going on in. So there's now an ASV file here, stats.asv. I thought I had a git ignore. I do. Then what? Oh, I see. Okay. Git commit. Added indices of extremum into stats.m. Into reporting by stats.m. By the way, I now have a GitHub repository for this project. Spirit reg. There it is. There's one person watching. Is that me? Yep, I'm the watcher. Okay. So you can now download the code at whatever point I've got it at github.com/endwork/stats or spirit reg. What's different with certconf? Oh, just added a comment. What's different in test work lib? Just a minor code cleanup. Very minor code cleanup. Now dworklib is up to date. Wonderful. We've been streaming for about half an hour. Why did I do all that with stats? Okay, now I want to run this. I want to see where there are the minimums. 9, 12, 17, 18, 59. Great. Now I want to see the corresponding location of A. So what is A of 59? What are its values? The 59th row of A. It is not 0. What is Y of 59? It did not give me a 0. W coil 59 is actually a 0. 95? Hold on, I'm confused. Okay. everything I just did looking into values of A and Y were looking at the 59th row of A was not correct. So now I just want to take the dot product of the 59th row of A with W coil. Okay. So multiply A 59 times W coil. What does that give me? That value. Okay. But somehow if I did the dot product, it's because it's complex. It's not just the dot. It's not just pointwise multiplication. Okay. Wait, no, that should have worked. So what is sum of A59 W coil? Oh, right. Okay. Because A is a row, yeah, okay. So A is a row. The 59th row of A is a row, of course. W coil is a column, so it was doing like an outer product there, I think. Something like that. But if we get it right, then it's, so now if I do A59 times W coil, this is just straight matrix multiplication now. So I don't know why that is different than that. Oh, because this is conjugate transpose, I think. Yeah, okay. Finally got it. A of 59 times W coil is that value. And what is Y of 59? That looks pretty close, doesn't it? Okay. I guess W coil can actually have zeros in locations other than the places I wanted to. I'm very surprised that it does. I would have thought, what is the rank of A? It's going to be full rank, of course, but what is like the, what are the singular values of A? I really do not like the static workplace stuff. Why can't I see new variables here? Why is that a problem? So the largest singular value is 13. The lowest singular value is 0.002. You know, no. Oh, that didn't happen. Oh. So the condition number is like 6,000. Not good. Is it terrible? It's pretty bad. And that might be the issue. Why is the number bad? It should be a highly overdetermined system. It's not. It's underdetermined. Well, that's a problem. Now it's overdetermined. I had to increase the size of the calibration region. When I do that, I get a 0 only where it should be. That took me so much of this while I'm streaming. I say to myself that this is taking me way too long. Like a novice could figure this out. Maybe they can. This is the best I can do. What's the image look like? Still have 1,000 iterations here. While LSQR is running, let's look into LSQR a little bit. So what I want to know is what the default tolerance is. The default tolerance is 1 times 10 to the negative 6. I'm guessing the tolerance is on the relative residual. Does MATLAB define the relative residual? LSQR tracks the relative residual and the least squares residual at each iteration in the solution. And the algorithm converges when either residual meets the specified tolerance. The relative residual error is that. And the least squares residual error is, okay. What is M here? What is B? The LSVEC output tracks the history of this residual over all iterations. Do I get LSVEC? I can. What is ResVec? ResVec. So I can have ResVec and I can have LSResVec. What is LSResVec again? Oh, LSResVec is this thing. I don't know what that is. Okay. This is run. What's the flag? It succeeded. Still looks bad. Why does that look bad? I guess there are 5 bugs to go. And when we solve one, there will still be 5 bugs to go. Flag relative res iter and resvec. LSQR iter, LSQR resvec. Let's put this at 1,000. Let's just see what the residual values are looking like for each iteration. And again, I want to look at K out. Still stripy. So it's not working. If SPIRiT were working, the reason that there are these stripes here, these darker stripes here, is because every other column are the values that were collected. And we're using SPIRiT to interpolate the missing values. And there's this general offset between the missing values, the values that we're estimating, and the values that were collected, which is why we're getting this stripy pattern. And that striping pattern is results in this aliasing pattern here, where we're getting a copy of the original angle kind of shifted over. And the reason we're only seeing the high frequencies is because the auto calibration region contains the low frequencies. So we're not aliasing the low frequencies, only the high frequencies. And so the question is, why is any of that happening? Oh, I meant to look at the residual. Do I just need to set the tolerance lower? Right now, the tolerance is set to 1 times 10 to the minus 6. That seems pretty good. But what if I set it to... Oh. Okay. There's an issue with MRI. Hold on. My phone seems to have stopped observing the stream. Okay, we're back. There's this issue with MRI. Oh, this is the issue. So here I'm normalizing the data. There's a scaling ambiguity with MRI. Inside the MRI machine, there's an amplifier. And the amplifier tries to make the machine sensitive to the signals that it's seeing. So if it's seeing very low signals, it amplifies them. And we don't know the setting for that amplifier, so we don't actually know the strength of the signals measured by the antennas inside the MRI machine. So what do you do? Well, the answer that people seem to have come up with is they allocate a certain number of bits, some arbitrary number of bits to represent signal intensities at any time. And then the amplifier tries to scale the signal so that the maximum value it sees exploits the full dynamic range of all those bits that we've allocated. Well, then what does a relative residual mean? Because I could arbitrarily change the scaling. I literally can change. If I have AX equals B and I have a million A, X equals a million B, those linear systems are solved by the same X, but the error is dramatically different. So to make values like tolerance meaningful, we normalize the data by dividing by the maximum, or I normalize the data by dividing by the maximum magnitude, so that after this, the magnitudes of the MR data go from a minimum of 0 to a maximum of 1 all the time. Okay. Let's just run it for until it reaches a tolerance of 1D minus 12, or for 1,000 iterations. And let's see what happens. Let's see if we still get the stripy pattern. If we do get the stripy pattern, if we don't get the stripy pattern, which would be surprising to me, honestly, then it's just an issue with letting LSQR run long enough to achieve the true answer. But if we do get the straight pattern, then what? Then it's not. Then it's not, a matter of the tolerance or letting it run forever. The issue is, I don't know. I don't know what the issue is. Another question is, so right now I'm using what's called Roma reconstruction. This comes from the paper, the NMR phased array, I think it was called. So I'm reconstructing the images of the individual coils, and then I'm combining the coil images using Roma reconstruction. I wonder what the images of the individual coils look like. Okay, so each coil's image is aliased. So it's not like a coil thing. This is happening for all the coils. That's not too surprising because, after all, we saw the straight pattern in the K-space of each coil. Here there are 8 coils, of course, so this is the K-space of both collected and estimated of the first coil, second coil, third coil, etc. LSQR is claiming that it did not succeed with 1,000 iterations. Oh, because I made the tolerance 1 times 10 to the negative 12. That's not surprising. Okay, so on a semi-log Y plot, it's going from an error of about 8 to an error of whatever the final error is, 7.65. And it's doing it within 200 iterations. It's doing it at 150 iterations. Okay, so at least for this A, unless we find an issue with this A, we can just do this for 150 iterations, not 1,000. It's not giving us the warning that A is rank deficient. Right now I'm initiating the estimated values to K to just zeros. So this is the original K data with the missing data, okay? I'm gonna look at just one coil. This is how I'm initiating the estimates with all zeros. And then they're trying to go about and figure out what the proper estimates are. But it would make sense. So here I'm showing it to you on a log plot, which is why instead of zeros, it's plotting out negative infinity. Whatever, it doesn't matter. It would be very reasonable to initiate the values not with zeros, but with the nearest K-space coordinate. Okay. That would be, an initialization that's closer to the final correct answer than straight zeros are, I would think, almost always. That's not super simple to do. Let's see, there's a function called scattered interpolant. Interpolate 2D or 3D scattered data. Let's do this. This will at least be some progress, and then that's maybe where we're going to leave it today. So, find sample mask. I only need to look at one coil. Find where they're equal to 0. Estimated indexes. Data indexes. Find sample mask. Not equal to 0. How about that? And then like y data indexes and x data indexes is equal to, it's either index to sub or sub to index, and I can never remember. Returns the array row and column containing the equivalent row and column substrings corresponding to the linear indexes. Great. So which one was that? I still can't remember. Index to sub. Index to sub. Data indexes. Well, those are the indices, aren't they? And then we need the size. Do we have the size anywhere? It's n by n. That'll do. Where's the query? XYV, so XY value. But how do I tell it which points I want to know? Oh, you create the scattered interpolant and then you query it at specific locations. Okay. So here we can create the scattered interpolant. We're going to do this for all coils. Now I can use coil index again. I'm going to need a place to store these values. Is it actually X? sure it matters. The query XY, right? I want to do nearest. Here's what I'm going to do. K naught is equal to zeros and est. 1. What is n est? Ns is for all coils. I guess I could just divide by the number of coils. That's, I guess, what I'll do. Ns divided by n coils, or by C? C, okay. So then K naught coil index is equal to XQ, YQ, okay. So there you go. Let's get here and see what these initial estimates look like. I'm going to do this, but instead of K star, I'm going to put K estimate here. No, I meant K estimate. Oh, okay. I guess I meant K naught. Ooh. Stripes. That shouldn't be. There's still zeros. Who's K naught? Stats K naught. It's all zero. They're all zeros. Okay, maybe I just don't need to put all of the indices here. It's not hurting, but I imagine if there are like 100,000 indices, that would be a problem. Did I forget to say this? Why did it do it for min but not for max? It's doing it fine for min, but not at all for max. So it's greater than, oh, okay. That was the issue. Okay, I like that. I guess I can make n extreme n2 display is equal to what, 15? Doesn't hurt, does it? Okay. K0's always 0. Always. K data, the data indices is always zeros. Find not equal to 0. That was the issue. K star is equal to K naught. Now I'm going to look what this is. K out. Okay. That looks like a decent initial first guess, doesn't it? There's clearly still stripes here, but not nearly as bad as before. It's a good first guess. What does LSQR do with that? This that we just did to come up with a better first guess for the optimization variable than just setting it to zeros or whatever, something simple, can be called warm starting. Okay, so we've still got the aliasing. And the striping is worse after doing the optimization. So it really thinks that this is the right answer. We're still stuck. And I think that's where we're going to leave it for today. Maybe we'll figure this out next stream. Until then, have a good one.